IVT stands for Integrated Vapor Transport, and it really measures how much water vapor or humidity is moving in an atmospheric river. And so we use it to really judge how strong an atmospheric river is. Pineapple Express is a way to say that the water vapor or that humidity in the storm is coming from somewhere much further south, like the tropical regions, maybe near Hawaii. That's where I think the name came from, and so that's kind of how I use it.
That makes sense, because we know we can get a big plume of moisture from areas away from Hawaii, much farther north.
Right. Yep. The water could come from very far north. It could come from cold regions, and it could come from the tropics too. IVT has to be provided by a model. And that's because we can't measure it at any one point. We have to measure all of the atmosphere between where we're standing and space, basically. So we don't have anything that can do that. Even satellites can't actually do that exactly. So we have to use the model data to get IVT. I typically look most at the GFS. I know that may, I'm not saying the GFS is better than the European model in terms of more accurate predictions, but because of the way that the data comes, you can look at a lot more interesting and detailed information for atmospheric rivers. And I think one of the websites we talked about, the CW3E website, has a lot of really interesting tools that are designed to just look at atmospheric river information in real-time events like this one. The Climate Science Lab is really trying to understand extreme precipitation events. So some of those really, really big historical events, and what are the drivers of those? So if we talk about like the Christmas Day storm, for example, what were the climate ingredients and the weather ingredients that went into making that such a big event? And so the Climate Science Lab has several students that are working on studies that would be either trying to understand events like that in the Pacific Northwest or understand events like that throughout the whole country. Atmospheric river impacts are actually related to both the strength of the atmospheric river, so that IVT, but also how long it lasts, the duration of the storm. And there's a new scale that was just published this last year that attempts to talk about that. So it's an atmospheric river impact scale. And the scale can be calculated by taking into account both the strength and the duration. And so because of the uncertainty in the duration of the upcoming atmospheric river, we're looking at potentially a change in the scale level from a 3 to potentially a 4. And that means different things for impacts. So atmospheric river scale 3 storms are typically carry about an equal mix of beneficial water supply impacts along with hazard impacts. But once we start to get into the AR category or AR scale 4 events, we're talking about more hazardous impacts than we are about beneficial impacts. My position at Portland State is a research position. So I am interfacing with projects that assist water management in developing new tools to understand the impacts of atmospheric rivers. And so some of those are understanding the uncertainty in the rainfall forecast. And so what is like the lowest possible amount of rain versus the highest possible amount of rain, understanding that range and what it means for operating reservoirs and other types of water management tools out there. And also in that role, we're looking at some climate data too. So that's really where I'm at. There are some other folks, Portland has a couple of different Army Corps of Engineer district offices, a division office, and they're more tasked with the day-to-day management. I talk to them conversationally, but I don't really provide them with direct information per se.